For this one, we're going to be doing an RL circuit, and we are going to be looking for IL. The first thing that we need to do is to figure out our initial conditions. So what's happening before this switch opens? So we can assume that the switch has been closed for a long time. All right, so we've reached steady state, and we know that when the inductor is connected to a DC source, that it's going to behave like a short circuit. So we can draw the circuit again and draw our inductor as a short. Now what we know about a short circuit is that it's going to take all of our current going through here, and so we can redraw our circuit again so it looks like this. Where this is IL. Okay, and so I'm going to use NVN here, call that V, and our equation is V minus 10 over 2 for this current, V over 12 for this current, V over 4 for this current, which is also IL. That's going to equal 0. I'm going to multiply out by 12. 6V minus 10 plus V plus 3V is going to be 0. If I combine my like terms here, V is going to end up being 6 volts. Okay? Now, once I have that V, I know that my IL 0 minus is going to be that V over 4. So IL 0 minus equals 1.5 amps. All right, so that's what's happening with the circuit right before you open the switch. Now, once you open the switch, you know that your inductor is not going to instantaneously have a change to its current. So that IL of 0 minus is still going to equal our IL at 0 plus, which is at 1.5 amps still. Okay, so now we want to look at as t approaches infinity. All right, so now the switch is open. So the left-hand side is not connected to the rest of the circuit. Okay, so our IL is not going to have any current flowing through it. So we can say IL at infinity is 0. All right, so now we want to find RTH so that we can determine our time constant. We can redraw the circuit after t equals 0. We can zero out that voltage source there, and we are going to figure out our R equivalent through the terminals of the inductor. So we are going to combine 4 and 12 in series. That will equal 16, and then we'll have 16 in parallel with 16, which is going to equal 8 ohms. We know that our time constant is L over that R equivalent, so that is going to be 0.25 seconds. All right, let's again put it in the standard form. And we end up with IL of t is going to be 1.5 e to the negative 4t amps. Okay.